What's up again, everyone? I'm Bea May Divinohi, and this is your Group 12 Buddies again, ready for a new challenge. So, someone they asked today. He dare us to make this balloon expand without blowing or adding any air inside of it, and this balloon shrinks without releasing any air inside of it. Challenge accepted. For this challenge, let's have this simple experiment. What we need is these two balloons. Let's mark this as the balloon A and this as the balloon B. We're also going to need a place that has a high temperature and a low temperature. In this case, at a container filled with hot water and inside the freezer. Now let's proceed to the experiment. Let's have this balloon A. The first challenge is to make it expand without blowing or adding any air inside. Before the experiment, its diameter is at 39.5 centimeter. Now let's put it on a hot water and wait for 5 minutes. After 5 minutes, it is now at 40 centimeter. It expands. Challenge accomplished. Now let's have this balloon B. The next challenge is to make this balloon shrink without releasing any air inside. Before the experiment, it is at 42 centimeter. Now let's throw it inside the freezer and wait for 5 minutes. After 5 minutes, it is now at 41 centimeter. It shrinks. Challenge accomplished. Wondering how that happened? It's because of the Charles' law. What is Charles' law? Here are my group mates Gillian Martirez and Steven Passon going to explain what just happened.
What is Charles' law? Charles' law is an experimental gas law that explains how gases tend to expand when heated. Physicist Charles studied the effect of temperature on the quantity of gas at a constant pressure. This law describes how gas expands because of the temperature increases. Conversely, a decrease in temperature will cause a decrease in volume.
Here, we have the volume and temperature as the variables and the pressure and number of mole of gas as a constant. You see in the experiment that when the balloon A is placed at a high temperature, it expands. And as what happened to balloon B, when we put it at a lower temperature, the balloon shrinks from here. We can see that volume and temperature are directly proportional to each other.
Why does balloon A expand? Why does balloon B shrink? Let's explain why.
The high temperature causes the balloon A to expand. Because of the kinetic energy of the gas, as the temperature increases, the gas particles inside the balloon move fast. While moving, these gas particles hit the walls of the balloon. And because the balloon exhibits elasticity, the balloon stretches and it expands.
Here we have balloon B, and after putting it at a low temperature, it shrinks. Unlike in high temperature, the kinetic energy of the gas in lower temperature is much less. When the balloon is placed at a low temperature, the gas particles inside move slower, causing the balloon to shrink. From this, we can conclude that volume is directly proportional to temperature while having a constant pressure and number of moles of gas.
Therefore, when the volume is high, the temperature is also high. When the volume is low, the temperature is also low. When the volume increases, the temperature is increased. When the volume decreases, the temperature is decreased.
The formula for Charles' law is initial volume, final temperature is equals to final volume, initial temperature.
And that is how it happens. We hope that you learned something new today. Bye-bye!